Welcome to this video. In this video, we will learn how to perform end value management problems in project management. Okay, so basically end value management, this topic helps us to assess the project's progress in terms of time and cost. It helps us to assess the project's progress in terms of time and cost. So we might have a project and then we plan to say probably maybe by next month or maybe by 2 weeks, we should achieve this amount of work. You might realize that as you go on, the project does not move according to the plan. So now we are checking the project to see whether we are behind time or we are ahead of time. So the word we'll be using is schedule. We are behind schedule or ahead of schedule. And then also the cost, we might have costed, we might have planned to say the project will cost us this much. And then you realize along the way that actually it's costing you less or more. So we need to check the project at some point and see how we are moving so that we can make provisions if we are under budgeting so that we can complete the project effectively. I'll go straight to the example. And then this is the example. Let me not say problem. Let me just say example here. Example, you have a project to build a new fence. The fence is four-sided as shown at left. It should be below, as shown below. Each side is to take 1 day. Very important information. According to the plan, a day we should build one side. So each side should take 1 day to build, and $1,000 has been budgeted per side. So according to the budget, 1,000 has been budgeted per side. Very important information. The sides are planned to be completed one after the other. Today is the end of day 3. Today is the end of day 3. Using the following project status chart, calculate planned value, end value, etc. in the spaces provided. So let me see the spaces provided. So this is the table that was being talked about when the examiner referred to the fence is four-sided as shown in the table below. So that's the table below. This one here. This is the table below. And then in this table, we're going to fit information which will help us to calculate planned value, end value, and etc. Now, you can see below here, there is a PV here, planned value, end value, actual cost, BAC, CV, CPI, SV, SPI. I will explain these things. And then I think it continues, EAC, etc, and BAC. Those are the most cardinal 11 computations that we need to perform in end value management. So let me start with the planned value. The planned value is the value of weight according to plan. So I'll go back to my notes to check what is it that we had planned. Okay, so according to plan, each side is to take 1 day to build, and today is the end of day 3. Meaning by end of day 3, if each side is taking 1 day to build, by end of day 3, we should have built 3 sides. So I'll come here and insert 3 there. And then each side, according to plan, each side costs $1,000. So now come here and multiply this by $1,000. And multiply this by $1,000. So I expect this sheet to be provided to me in the exam. Then the answer there, I'll float it there. I'll say $3,000, 1,000 multiplied by 3 is $3,000. And then my interpretation will be, this is the value of work that should have been done by now. I'm not saying this is the value of work which has been done, but that should have been done. I go to the next computation. So PV is according to the plan or according to schedule, according to time. Now I come to EV end value. EV is end value. End value is the value of the work which has been done. Not the work that should have been done, but the actual work which has been done. So I'll go to the status chart to go and see how much work has been done. So if you look at the status chart at end of day 3, you look at side 1. What has happened to side 1? Side 1 is complete. I'm not looking at the amount spent. No. I'm just looking at the work which has been done. Side 2, complete. So we've got 2 sides complete. Side 3, 50%. Side 4, not yet touched. So we've completed 2 sides. This one, side 1 is complete, side 2 is complete, and side 3 is at 50%. So we've got 2.5 worth of work done. We've done 2.5, 2.5. So we'll say side 1 complete plus side 2 plus 50%, which is 0.5. This will give us 2.5. So we have 2.5 worth of work done, not the work that should have been done, but the work which has been done. Multiply by 1,000. This gives us 2.5. This is the value of work done. AC actual cost at this point. AC actual cost at this point. I'm just going to count or to calculate the total cost. 1,000 was spent for side 1. 1,2 was spent for side 2, and 600 for side 3. Nothing spent for side 4. So 1,000 plus 1,2 plus 600 actual cost. 1,000 plus 1,2 plus 600. Answer here, this is 2.8. The amount spent, the actual amount spent. That's the interpretation. But is budgeted at completion, meaning the total budget of the project. So if the project was to build 4 sides and each side cost $1, the budgeted at completion will be 4 multiplied by $1,000. Yeah, each side costs $1,000. Sorry. So I'll say 4 multiplied by $1,000. This will give me 4,000. The total budget of the project. Budgeted at completion. The next computation is cost variance. Now listen to me very carefully here. The next computation is cost variance. How do we calculate the cost variance? Now I'll tell you one thing. In EVM, end value is one computation that is widely used in calculating the index and the variances. In case you didn't hear me, in calculating the index and the variances. So the variance is actually minus, we are subtracting. The index is actually division, we are dividing. Now, when we say EV is very important, I simply mean in all the variance EV will be found, and in all the indices EV will be found. So EV is always in front when we say variance, and then we say minus. It's either we are minusing planned value or actual cost. It's either we are minusing planned value or actual cost. So in short, I can simply say EV works with AC and PV. When AC is involved, there will be a weight cost. When AC is involved, which is actual cost, there will be a weight cost. When planned value is involved, there will be a weight schedule. So let's see the first one. No, let me leave that here. I'll be referring to it. This is a tutorial, so I'd love to leave it here. EV will be there. And then index, we are dividing, and it will be EV divide by something. And that something can be cost or planned value. Can be cost or planned value. So let's see. Cost variance. Cost variance, because of the weight cost, it simply means that actual cost is involved. Cost variance, because of the weight cost, it simply means that actual cost is involved. So it will be, remember the variance, it will be EV minus AC. Remember, EV is always present, minus AC. Our EV is 2.5 and our AC is 2.8. Yeah, I still want to keep the formulas there. Cost variance, because of the weight cost, it simply means that actual cost is involved. So it will be EV minus AC. So this will give me negative $300. Interpretation, are we over budget, or because we are looking at it from the cost angle, cost variance, we need to see whether we are over budget or we are moving well. So in this sense, it simply suggests that we are overspending, we are over budget. We are over budget by 300. I will explain that one. The value, remember, EV gives us the value of work which has been done. Then AC gives us what has actually been spent. So the value of work which has been done is 2.5, and then you go and spend 2.8, meaning you are over budget. Cost performance index, CPI, because of the weight cost, it simply means that actual cost will be involved. So cost performance index will be EV over AC. Remember what I said? Index is division, and EV is always present in either a variance or an index, but it will depend. So if it's cost performance index, it's EV over AC, which is 25 divided by 28. over 28. It's giving me 0.893, rounded off. Since we're interpreting things as cost, because it's cost performance index, we need to look at it as cost. So it simply means that for every dollar we spend, every dollar, meaning $1 we spend, we are getting work, we get work worthy 0.893 or for every dollar that you spend, you're getting work worthy 89 cents. So you're overspending. You're spending $1, but the work that you're getting, the value of the work that you're getting is 89 cents. You're overspending. So these two have agreed. The variance suggested that you're overspending, and the cost performance index suggested that you're overspending. Schedule variance. Schedule variance. Schedule variance, because of the word schedule, it simply means that planned value is involved. Remember, there are only two things: schedule and cost. Schedule and cost. Cost meaning actual cost is involved. Schedule means planned value is involved. So schedule variance is EV. Remember, EV is always there, minus PV. And because it's schedule, we are looking at things in terms of time. And our EV as calculated is 25. And planned value is 3,000. In interpretation, this will be negative 500. That's the answer. Negative $500. In interpretation, we'll say this. Remember, EV is the value of work done. PV is the value of work that should have been done. Remember, the value of work that should have been done. So if the value of work that has been done is 25, when we should have done work worthy 3,000, it simply means that we are behind schedule. So I'll write here, we are behind schedule. Behind schedule. SPI is schedule performance index. Because of the way schedule PV is involved and it's an index, so it will be EV over PV, like that. So this will be 25 divided by PV, which is 3,000. What do we get? 25 divided by 3,000. We are getting 0.833. We are getting 0.833. What does this mean? Since we are looking at it in terms of time, we will simply say we are moving at 83%. 83% of plan, when we should have been moving at 100%. So we are behind schedule. EX is estimated at completion. EX is estimated at completion because we are now overspending. we want to see what would be the actual cost, because the total budget indicates that we should have spent 4,000 for the whole project, but it looks like we're not going to spend that because we are overspending here. So EAC will be, EAC is calculated as BAC over CPI. BAC over CPI. BAC over CPI. The BAC is 4,000 and CPI is BAC, which is budget and completion. CPI, we found it here. It is 0.893. On my way, boss. On my way, boss. On my way. Okay. Okay. All right, sorry about that. So BAC is basically EAC, estimated at completion, is basically BAC over CPI. So this is the new cost. We thought this project was going to cost us 4,000. It will actually cost us 4,479. New estimated cost. ETC is estimated to completion. Like how much more should we spend to complete the project? Okay, how much more should we spend to complete the project? So ETC is going to be calculated as EAC, which is the new estimate, minus AC, what we have already spent. We just want to see how much more we are going to spend to complete the project. How much more are we going to spend to complete the project? So it will be 4,479 minus what we've already spent, which is 2,800, the actual cost. So we're going to spend 1,679 more. The amount needed to complete the project. ETC. BAC is variance at completion, meaning the total variance. It shall be BAC, which was the original budget, minus the new estimated budget, which is EAC, estimated at completion. So it shall be 4,000 minus 479. So it will be negative 479 as VAT. Interpretation, total variance of the project. Thank you for joining me through. This marks the end of the tutorial as per requirement by the examiner.